Now, one thing that this does not do, and you may have noticed, is this fraction there is not simplified. So 12/8 or 12/18 can be simplified to, what is that? Let's see, what's the common divisor? 6? So that would end up being 2 and 3. So this is equivalent to 2/3. So what you end up doing is when you have a fraction, you have to find the greatest common divisor, the number which will go into both of these, and then you divide the numerator by that number and the denominator by that number. And whenever you divide that, then you get back the lowest possible shared value, or the lowest value between those two, using that shared common divisor, and that gets you the simplified fraction. So it would be nice that, we have the addition here. Let's go ahead and modify this to then simplify a fraction because, well, if I go back to high school or elementary school or middle school, whatever school they teach fractions and algebra in, well, I will have a program to where I don't have to figure it out anymore. I can just type it into the program, put the answer there, and the instructor has to give me an A, hopefully. So let's go ahead and write that. So we want a public static fraction simplify. And for this, we want to take in a fraction and input fraction. So we want this method, when we call this method, we give it a fraction to then simplify that fraction. Now we could, instead of taking it in as parameter, we could operate on the fraction that we have, but I'm using this so that I can add it up into my addition operator. This is static so that we can actually call it from anywhere. We don't have to worry about creating an instance of fraction in order to simplify a fraction. We can just pass in a fraction there. So what do we do for this? So we need to find a greatest common divisor. Int greatest common divisor. So we need a greatest common divisor, and then we need to actually return a fraction. Return new fraction, and for now I'm just going to return 0, 0. So this will be a fraction 0, 0, which isn't, 0 divided by 0, but anyway. So now how do we determine the greatest common divisor? Well, to find the greatest common divisor, what you do is you start with this, you compare these two, you see what the modulus of that is, and whatever the modulus, you keep going until the modulus is 0. And you basically recursively shrink your searching space. So you can find algorithms online, but I'm going to go ahead and write a method, private static int GCD, and this will take in 2 integers. And so I'm making this private because this is a greatest common divisor for my fractions. I don't want anybody to just pass in 2 numbers. I could create a separate class and then add it in here, but I want this static, or I want this private so that it's only accessible from inside of my fraction class. This static is so that I can call it from up here, or I can call it from anywhere else. And actually, I don't even need this static, come to think of it. But I do need this int. I do need to return an int. We'll see. I may need to add that static back in. But now, I just say if b is equal to 0. So if we are already at 0, if we found the greatest common divisor, return b. If we have not, we're going to return the greatest common divisor, passing in b in place of a, and then a mod b in place of b. So we're recursively calling this method, passing in b, whatever our denominator was, and our new denominator is the result of a mod b. So we're taking the numerator, modding it with b, and then we'll putting that in as basically the new denominator, if you want to think of it like that. And we keep going through there. And once we get to this where b is 0, that means that a mod b is 0, means that, well, we found the greatest common divisor, which we had previously set in b. We're just going to return that. So the first iteration of this, so let's go ahead and write this out. So console.write line, and just visualize this execution a bit. So we'll go ahead and say A, and B. So we can see this in action. And so up here, so we have this right here. But up here, we're going to go ahead and call it greatest common divisor is equal to GCD, so whatever we get back from that. And then we want to pass in input fraction dot numerator and input fraction dot denominator. So we're passing those in. So just for fun, let's go ahead and see what this actually does. This is static, so I can go ahead and call it down here. So I will go ahead and say, let's say this will be fraction dot simplify, because again, it's a static method. I can go ahead and call it directly. I need to give it a fraction, and this fraction will be a, I'll do this 12/18. Let's say I need to do new. I still need to create a fraction inside of there because I have to pass it a fraction, but I'm just creating a fraction on the fly. I'm not storing it anywhere. I'm calling that method from here, and this will run through there and do it. Method delegate, or let's see, I probably need to, oh, no, I need to say GCD. That's what I need to do. And cannot access non-static method GCD in static context. Okay, because this is static, I have to make this static. I forgot about that. See, my notes had static down there, but I forgot exactly why I had that. So, both of these, if you have a static one and you're calling another method from that static method, that both methods have to be static. So, let's go ahead and see if this runs, see what we get. Okay, so the first iteration, A is 12. B is 18, because that's what we passed in. The next iteration, A is 18, B is 12, because 12 mod 18 is going to give you back 12. And the next iteration, B is 12, or A is 12, B is 6, because 18 mod 12 is going to give you back 6. The next iteration, A is 6. Notice that B is always becoming A. The next iteration, B is 6, or A is 6, B is 0, because 6 mod 6 is going to be 0. And so now that we have a 0, or actually 12 mod 6 is going to be 0. And so now that we actually have a 0 there, we return 0. So that shows you the recursiveness of this method. And so at the end, it's going to return B, and it just kind of unwinds everything as you do that. So if you're unfamiliar with recursion, then go back and read up on some recursion. It's basically just an onion. You're just basically peeling back layers until you get to the core. And so once we get back there, we have our greatest common divisor. And now we just take input fraction divided by the greatest common divisor, or input fraction dot numerator and input fraction dot denominator divided by greatest common divisor. And that returns a fraction. So we can look here, we will see a fraction, and that will return a fraction, and we can go ahead and say console.write line, and we can print out the result of that. So if we run this, we will get unhandled exception divide by 0. That's because we are calling simplify and everything else. So We'll have to fix that in the next video. This one became a little long.